an audio test, so give me like 30 seconds to make sure my mic is going through.
Sounds great. It's so funny how many Fast AI alumni are all over deep learning, because I learned deep learning from Fast AI too. So it's kind
Oh
of
no way.
yeah.
We have another one. Yeah, it's like everyone's a fast AI student unless they're not. I can hear
Exactly.
myself. Awesome. Hey everyone, thanks for joining. As you can see, fortunately, it's not just me in this live stream. So we'll be talking to the author Lewis Tunstall today, who's written this incredible book that we plan to cover in the next few weeks. If you just click on this video, I'll give an intro to the study group and then there'll be an Ask Me Anything with Lewis. So let me start by introducing Lewis to everyone. His Twitter handle is @_Luton, and he holds a PhD in theoretical physics. He studied some things in nuclear physics, which I fail to understand. And he's most well known as the co-author of the courses and books by Hugging Face. So thanks again for joining me, Lewis, today.
Thank you very much for having me. I'm excited to be here and answer any questions you or the community have.
Yeah, so I'm sure everyone noticed everyone's too excited just to dive into the book. So I thought, what better chance than inviting the author himself to start with this? There's a thing in our culture, in Indian culture, where the teacher gives you directions. So that was my intention with this. Ask Me Anything.
Great. Sounds good.
So what I'll do is I'll waste your 5 minutes and I'll just tell the structure to everyone since this is the first live stream, and then we can get into the Ask Me Anything. So for the audience, please drop your questions in the chat and I'll be asking them to Lewis. So the first 30 minutes are for you. I'll quickly outline the structure. We'll meet every Saturday at 8 a.m. Pacific. So I'll live stream every Saturday. The easiest way is either you can subscribe or I'll just tweet out the links every day, and these will be paced with the book chapters, and I'll share additional materials. So the agenda for today is we'll start with then Ask Me Anything, and then I'll cover the first two chapters. And I wanted to drop a few ethical warnings or just some mentions that, hey, please consider purchasing the book. Even though we'll be going through the GitHub notebooks, I would highly recommend that you buy the book. I've really enjoyed it, and I'm sure you'll learn even more if you go to the book as well. This is supposed to be a supplementary material and not replace the book. Apart from that, I'll also keep sharing Kaggle resources and some discussions around that. So you're also welcome to check those out. And I'll always be sharing those links right under the like button in the description of these videos. One more thing I'll mention, you're welcome to join the H2AI forums, which I'll share a link to. So I'll also keep the discussions there. I found that the long form discussions usually end up better on community forums, and the live chat is for live chat. So that's all for the housekeeping and just the general stuff. I'll now start asking stupid questions to Lewis, and hopefully better ones will come from you. So Lewis, I really like the Australian culture. I like in a good way. Aussies are amazing people to talk to. I know you're from Australia.
Yeah,
What's
that's
the
right.
most what's the most Australian language model, if I may?
Yeah, so I was thinking about this question, and it's not so easy to answer, right? Because I actually looked up that there's very little like Australian sort of slang. So obviously one of the things that Australia is famous for is like the way we speak, which is often with like made up words, and we concatenate everything. So for example, chocolate biscuit is chocky bicky, and a barbecue is a barbie and stuff like that. And
Brekkie is
so
breakfast.
exactly. So I was kind of curious, like, are there any like sort of language models that have been like sort of fine-tuned on Australian slang? And I couldn't find any on the hub so far. So I think probably like depends how you count it, but probably the like most sort of Australian models are actually the ones coming from Jeremy Howard at Fast AI. So I mean he's Australian too, so probably his models have the closest thing to being Australian on them. But yeah, like at the moment, as far as I know, no one has done this, and it might be a fun project, right? If you can scrape a bunch of Australian kind of idioms and then train like a a GPT-2 model on it, that would be kind of funny. But unfortunately, I don't know any others at this stage.
Tom says it's a true gap in the market. I think we both agree.
Exactly.
And you were talking about this, but like in terms of transformer slang, is there like a pre-training in theoretical physics that makes you awesome in NLP? Because it's true to Thomas as well, I believe.
Yeah, I don't think there's like an obvious correlation, but one thing that's strange is that in industry, the number of people I've met with like backgrounds in the natural sciences is quite high, and I think the one thing that you learn from doing something like physics is dealing with a lot of like uncertainty, because most of the time the things you do are wrong. So for example, when I was working as a researcher, a lot of the time I was developing or trying to solve very difficult equations, and you need a lot of like kind of determination to grind through that. And the experience in like machine learning is kind of similar, because almost never does my code work. It's always got like bugs, or even just silent things. Like everyone who's ever trained a neural network knows that you get silent failures, like the loss doesn't converge, and you're like, what's going on? So I think it's maybe just more those properties of how you're trained to sort of be very sort of stubborn about solving a problem. And then maybe also the other element of trying to think about like how you frame hypotheses and structure your experiments. That kind of helps a lot. But yeah, like I don't know if there's anything else beyond that, except I should also mention Leandro is also a physicist. So all
Hmm.
three authors of Transformers are not really even real NLP researchers.
But it's good to know that I don't need a PhD in physics to be good at NLP. Sounds like
No,
it.
no, definitely
Maybe.
not. Definitely not. Definitely not. No, 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 definitely not. And I think it's also one of the things that, like, when I started out in data science, it was maybe in around 2016. At the time, there was a very strong, I would say, bias towards people with PhDs. So, in the sense that if you had a PhD, you got a job interview just because you had one, right?
Hmm.
And my personal experience, and also having worked with other people who came from these like academic backgrounds, is you're at a bit of a disadvantage because you're so used to thinking on very long time horizons, and you're not necessarily the best coder and all these things. That I would say today there's much better, or a stronger bias, I would say, and a good one, towards younger people who perhaps have some decent coding experience. And I would say that's the main, I would say, prerequisite. And of course, fast AI, as Jeremy has shown, really empowers people to get into the sort of deep learning side of things.
Yeah, I totally agree with Fast AI. I keep sharing it. People assume I'm being paid by them. Unfortunately, nothing. No money has made to my account so far from Fast AI. But I'll keep sharing it in the future as well. As a reminder to everyone watching live, please keep asking your questions for Lewis. So the first half an hour is an Ask Me Anything with him. Coming to your book, it's an amazing read. I've been constantly going through the pages. What can people joining the study group expect from the book if you were to like give them a highlight?
Yeah, great question. So when we wrote the book, we sort of really had industry practitioners in mind. And that's partly because Leandro and myself, we at the time were working in industry, trying to solve more like applied use cases with transformers. So, for example, the first thing I ever worked on was question answering, extractive question answering. And the thing that I found at the time, and this was a few years ago, it's much better now, is that there were very few kind of, let's say, guides on applying the methods, that exist in, say, the Transformers documentation to some sort of more real world applications. And so almost every chapter in the book is focused on like a single use case. So we tried to think quite hard about, what is something that either we had seen ourselves in our own jobs, or something that we knew other people had done. And then we try to frame the chapter itself kind of end to end as like, all the way from loading data, processing it, to training models. And then one of the things that we sort of put some effort in was also debugging, and, well, not debugging, but more like inspecting the outputs of your model. Because a lot of, like, say, tutorials on machine learning, they focus a lot on like, oh, train a model, accuracy is 90%, done, go home. And as you know, right, like that's sort of like step one, but then step two is really trying to understand like, okay, what are the errors that the model makes? Is there something that one can do about it? And so in some of the chapters, we also do a bit of this kind of error analysis, which for us in our own jobs was very essential. So I would say it's like a journey of these use cases, going from like maybe the simplest ones, which are like classification, all the way till the very last chapter, which is quite ambitious, is pre-training your own model, and in fact pre-training a kind of codex model for code generation. So we hope you get to see the full spectrum from fine tuning on Colab to renting an NVIDIA DGX workstation.
Yeah, I'm excited about the later half for sure. Thanks for the overview. I also wanted to point out the documentation by the Hugging Face team also reflects your philosophy about really making all of this accessible. You have the tutorials which are more handheld. There are also references, and it's really well written. It definitely comes through, which I'm sure the team puts in a lot of effort for.
Yeah, this idea actually came from one of my colleagues called Stephen Liu at Hugging Face, and he really showed us this idea of this quadrant, which is a kind of interesting way of framing software documentation. So you try to make sure that, like, if you're a beginner just landing on the documentation, you can go somewhere and learn something, like learn a concept. But if you're like a very experienced power user, you don't want to have to go through a big long list of contents. And so this kind of quadrant of needs, I think it was pioneered by a group called Divio, I think. But it's quite a nice one. So if other people are also writing software, open source software, I find it quite handy.
Yeah, I had interviewed Julian, I think 4 years ago, and back then I said Hugging Face is like the Apple of NLP. I think it's been true ever since. So there's a question in the chat, and I'll try to rephrase that. They're asking what are relevant tasks to learn in NLP, and I would rephrase it to like, what homework should we do while reading the book, or what would you recommend to us as your students, if I may?
Yeah, sure. So I would say there's maybe two types of homework I could think of. One, which is maybe the most important one, is to just run the code that we have on GitHub for the notebooks, and we have links to like Colab and Kaggle, and the vast majority of them they should run, I think, almost out of the box on one GPU. And the reason I say that is again inspired from Past AI, which is like the best way to learn is by doing, and it's only when you really run code that you kind of learn firsthand. Oh, I understand what's going into this function or into this class, what's going out. That would be my main homework. I would suggest is really just being able to run end to end the notebook chapter, and then the sort of other part of that. If we're thinking about like things like ChatGPT, even though they're as well, I mean, no one really knows exactly how it's made, right, except for OpenAI. But we can take a guess at what the kind of main ingredients are based on their previous papers. And one of the things that I would recommend reading is a paper called Instruct GPT, or well, it's the Instruct GPT paper, but it's called like Learning to Align to Human Preferences or something. I don't have the paper here with me, but it's I can send it to you later, and you can share it in the study group. And this paper is really interesting. It gives you a kind of blueprint of like, how do you go from a language model?
Is this the paper?
Exactly, that's the one. Yep, aligning language models to follow instructions. So this is kind of a landmark paper in the field, because essentially what they showed is how you can take a generative model, like a kind of GPT model, like the thing that everyone has probably played with at some time, and how you can, through a series of steps, convert that model into something which is trained to basically predict the next word in a sequence, and it can kind of spit out random stuff, to something that can actually follow the instructions of a user. So you can say, for example, I don't know, write me a cooking recipe using these ingredients, and then it will come up with some dish and it will give you the ingredients. And if you try to do that with GPT-2, for example, it won't know it won't basically know what to do. It will just try to autocomplete your input, and it just gets confused. And they sort of showed that in their paper, there's basically like two main ingredients needed to get to this like kind of more sophisticated language model. And the first one was to collect a lot of like data, which has been essentially labeled with these instructions. So you have lots of examples of people saying like, write me a recipe, or I don't know, summarize this document. And then you have humans really are creating these demonstrations. So people give examples and then you can see it. And then if you train a model in that on that kind of data, so you basically take a GPT model, you fine tune it on that data set, you'll get something which is much better at following instructions. But what they found is that even though that's a good thing, the downside is you can also ask the model to tell you, for example, how to hijack a car, and it will very happily, it will help you. It'll go, yeah, sure, I can do that for you, and it will give you, some instructions. So the kind of key step in their process after that was to take one of these kind of very helpful models, but potentially, dangerous ones, and then collect a lot of human kind of feedback, basically by showing humans, here are a bunch of outputs to some inputs, like, some questions. Which one would you rate as being, let's say potentially, I don't know how they did exactly, but say more harmless or something. And this process, if you combine that with reinforcement learning, you now have a way of kind of to optimize your original model to be able to generate outputs that are far more aligned with the preferences or the feedback that the human labelers gave. So to go back to this original question about, what skills should I learn? It's still effectively all NLP. You're still essentially training language models. You're then fine tuning them. And then the sort of extra bit that is not so common in the NLP toolbox is the reinforcement learning component. So my suggestion would be to read that paper and then, see, what you can learn from that. But my kind of hunch is that the vast majority of NLP tasks will stay valuable because, even though ChatGPT is here, a lot of people are still working with tabular data, right? So
Yeah. I'll definitely check out Instruct GPT and ask it how to end all coffee machines in like a single click.
oh,
So
that's right. I forgot you're the
yeah.
tea guy.
That sounds like our next live stream, everyone. So we'll do that in the next live stream. Jokes apart, on Chat GPT, are you like fascinated by what the hype it's created, if I may? So like my personal take has been like I know how an LSTM used to work, and it makes sense that if you throw 49% at a problem, Chat GPT could potentially solve it. Are you like fascinated by it, or like what's your take on that?
Yeah. Personally, I would say it's the most impressive piece of technology I think I've ever seen, involving language models and maybe even as far as you could say deep learning. So I think the reason for me personally is that with like DALL-E and Stable Diffusion, it was always cool to like play around and generate images and share them with your friends. But with ChatGPT, what's quite different is you can actually probe it. It's a little bit like talking to like a bit of an alien intelligence. So you can probe it for like very advanced things. Like I sort of asked it lots of questions around theoretical physics, and I tried to teach it how to prove some math theorems. And the experience was quite interesting. It's like on some things it's quite smart, on some things it's terribly stupid. But it has this element of dialogue, which is something I hadn't seen before, personally. So I think most people in the field were kind of skeptical that chatbots were, ever going to be, useful. And here you had a pretty nice example of something that could sustain a conversation over, a long range of topics. And the other element of this is that in the same way that I think Stable Diffusion really broke through the public consciousness, and maybe even DALL-E Mini is the best example where it went viral, right? So you had friends sharing, who knew nothing about deep learning, sharing stuff with me. I think ChatGPT did the same because something has changed the public consciousness when your parents start sending you ChatGPT outputs, right?
Yeah.
And an example is like my dad, he used ChatGPT to write a poem for like the end of year dinner at his work. So he basically typed in the name of his workplace and the sort of topics, and then it generated a really funny poem. And then I told him, do it in the style of this famous Australian poet. called Banjo Patterson, and he then it translated it basically into the style. And this is like, this is quite cool. So maybe the litmus test is like, if your parents are telling you about something, it's probably important.
That's a really cool litmus test. I was just being sassy. My point was that I've been like, I spend a lot of time on TikTok, and on there you see like they call it this AI that's doing magical stuff like that. That's not surprising to me, but like the feats of engineering and what's going on behind is like, of course, impressive how they're like even managing to serve it to so many people.
Yeah, and in fact, you can see it already today, right? Half the time ChatGPT is offline, right? Because it's getting so much traffic.
Yeah. So the next question is also from the audience. Do you personally have like a favorite NLP task that you like to solve or that you're working on improving?
Yeah, so I'm not sure if it's a task per se, but in the last couple of weeks, I've been working a lot with large language models. So more the generative task. So what I've been trying to do is understand, in the space of like open source models, which of the kind of ones that we have right now are like sort of comparable in any sense to like, what you see in like ChatGPT and stuff. And talking to these models is kind of fun, because you can ask them lots of questions, and a lot of the time they'll just spit out, like quite like fun things. Like, so for example, like I asked Flanty5 to come up with a metaphor for love, and it had, first of all, a bunch of like cheesy pickup lines, followed by something like, I'm like a frog is to water as love is to something. And so it has like these like, kind of humorous outputs, which for me, who has often worked more with like encoder models where you're just doing prediction, actually having this kind of like dialogue feedback is quite a fun experience. So I would say that right now, focusing on text generation is kind of the task that I like.
Makes sense. Thanks. I When I had interviewed Thomas, he said he used to like Bert at that time because it's like cheesy and almost romantic with its answers when it comes up with those. So his answer was that
Yeah,
about 3 years ago.
yeah. So actually, if you look at the last chapter of the book, Thomas, who wrote that chapter, he shows that if you take like GPT-2 and I think GPT-1, they have quite different personalities because of the training data. So GPT-1, or I think GPT-2 is a bit more romantic from memory.
It's interesting to see that all of these language models also have a personality of sorts just based on their pre-training. So that's also like a really cool thing.
Yeah, exactly. And one of the interesting things I discovered just a few weeks ago is if you condition the model with a certain kind of prompt. So you say, okay, the following is a friendly conversation between an AI and a human, blah, blah, blah. And you give some examples of what that conversation is like, you can change the personality of the language model. So you can switch it from being friendly and helpful to being, very mean and sarcastic. And it's kind of, it's not just the pre-training data. I mean, that's important, but it's also the way you kind of condition the model for the generative part. It's interesting.
Makes sense. Tom is asking a relevant question. Do you expect a further increase in the use of reinforcement learning in SOTA models?
Yeah, that's a very good question. I think the answer is we don't know yet. So I think it's quite clear that OpenAI and Anthropic, which is the sort of spin-off of OpenAI researchers, who as far as I understand, they're the ones who also kind of pioneered reinforcement learning at OpenAI. They're obviously going to use this technique in all their future work because they figured it out, right? They know that it works, that they get good results. I think what's a bit less known is, does it have to be reinforcement learning? So if I take this instruction model, so something that was trained on lots of these human demonstrations, can I achieve something similar to like ChatGPT by doing some other clever tricks? And pardon me, I think that is not super well known yet. There are some recent papers trying to show that you can do without the RL part. So I could kind of imagine there's like maybe two branches. There's like a branch of research labs that is going to really focus on the RL thing, and then there's a branch that's going to try and find alternatives. And at the end of the day, we may discover that RL is just one of several possibilities that happen to be the first that was picked, right? And yeah, OpenAI actually has some interesting work in the Web GPT paper, where they basically show that instead of using reinforcement learning to do this like optimization step where you kind of update your model to be more kind of aligned with the human preferences, you can use another very simple technique called rejection sampling to do that. And they show that it gets quite competitive with RL. So yeah, long story short, I don't think the answer is that. We will see.
Makes sense. Also, Karpathy is back at OpenAI, so more exciting stuff. Maybe, hopefully, will come from OpenAI. Also, they're legendary folks already, so we just got one more legend joining them.
I know. Hopefully, he keeps making open source, right?
Yeah, and those YouTube videos as well. He's a legend in them.
Yep, amazing.
So the next question is also for your preference of go-to frameworks while writing custom language models. Is it PyTorch or I think they meant JAX or maybe TensorFlow?
Yeah, so personally, I'm a PyTorch person, just out of historical accident. I think basically because FastAI was in PyTorch, so that's how I learned. So yeah, I write all my code in PyTorch. However, I do know that like Flax and JAX on TPUs, as far as I know, is like state of the art when it comes to speed of training. So there's like a framework called I think T5X from Google, which has a bunch of common architectures written in JAX. And as far as I know, this is like perhaps the fastest way to train a large language model on TPUs. If you don't have TPUs though, then probably you're going to need something like Accelerate and Deep Speed, which are the sort of in-house most common tools we use at Hugging Face for training, language models in the kind of, 10 to maybe 50 billion parameter size. And then after that, you have to start getting into weird things like Megatron and stuff like that. So
Thanks for that answer. I have 4 GPUs, but I have never dared to train a large language model. So maybe that's also worth an experiment for me. The next question is what open source large language models are best in terms of performance?
yeah, that's a really interesting question. So I was asking myself this question just a few weeks ago. And I think it's important also to mention that like when people say GPT-3, there's actually quite a large number of GPT-3 models from OpenAI. I'll see if I can actually dig it up. Just give me a sec, because so there's this thing called the Model Index for Researchers at OpenAI. And if you bring that up, I'll send it to you in the private chat if you want.
Sure.
So obviously, several years ago, OpenAI, sort of announced GPT-3. But since then, they've gone, much further than just plain language modeling. So they've done, the things with reinforcement learning. They've done these instruction models. And so there's a model called DaVinci, what they call an engine. And that, as far as we know, is like the closest thing to a kind of, let's say, conventional language model, so conventional GPT model. And the sort of two closest, there's maybe 3 kind of open source models that are kind of close-ish to that DaVinci model. So the first one, which I think is potentially the best model right now, is GPT Neo X. This is a 20 billion parameter model trained by Elutha. And they show in their blog post that, comparatively to DaVinci, they do quite well on a range of NLP tasks. And this model has also been trained on code, so it has that other kind of cool feature that it can, solve some coding puzzles. And then the OPT models from Meta, they, as far as I'm aware, they're kind of comparatively similar to the DaVinci engine. And then Bloom, but Bloom is a bit, handicapped on English benchmarks because it's a multilingual model. So a lot of people say, Bloom isn't as good as blah, and there is some truth into that, but probably you'd want to do like a fair comparison, comparing multilingual benchmarks to say GPT, or the DaVinci engine. So those are probably like the three ones. Now, if we go beyond DaVinci and you say, okay, what about instruction models? I would say the sort of two best ones that I know of right now is Flan T5, which is essentially a T5 model from Google that was trained on a sort of large number of tasks. So these were data sets that they basically collected from, open data. And then they're framed in this kind of like, question answer or, instruction demonstration thing. And this model, there was a recent paper by Google called the Flan Collection, where they show that, Flan T5 is, the best, say, open source model at following instructions on academic benchmarks. However, there is a second one, which I will send you quickly, coming from a project called Open Assistant. Have you heard of this?
I have not.
Okay.
I think Yannick mentioned this.
Exactly. So this is like an initiative from Yannick and the Lion team. So Lion is like a kind of open research collective. Pardon me. And essentially, this is a preliminary model from the collaboration, which has been trained to follow instructions using a lot of like clever tricks, and it's very good. I would say having interacted with it for the last couple of days, it's far more conversational than Flan T5, for example. So I haven't done like a quantitative evaluation, but my first impressions is that it's very impressive. So if you want to start with that, that would probably be the place to go.
The go-to backbone for Kagglers is Deberta V3 large, or sometimes just the small model. So that's what we end up interacting with the most.
Exactly, and I think probably in the next 6 months we're going to see, I would say, a large number of these instruction models appearing on the hub, and they will be the foundation for people then to build, for example, the reinforcement learning components with. And I think that's like quite exciting. It feels very much like the beginning of Stable Diffusion, where you've seen something which was DALL-E and it was closed source, and now you've got this huge energy, both from Open Assistant and also at Hugging Face to try and make this kind of technology both open source, but also the tools around it, because a lot of this is quite new, right?
There's an interesting question along similar lines. How much of the book is written by Copilot?
Yeah, so I think I don't know the percentage. It's hard to say because I wrote at least all of my parts in VS Code using like the notebooks, and I think Copilot only came really online maybe towards the end of the project. So it's probably the later chapters where it got better. But yeah, it's in general it's like one of those things where it works quite well, but when you're trying to write like a technical document, I found a lot of the time it would kind of just regurgitate some like doc string or something, or docs from other code it had seen, and you want to tell a story, right? And so far at the time, I think Copilot wasn't really powerful enough to kind of synthesize very large amounts of text, right? Because we're talking about now 30 pages in a chapter, and trying to write the conclusion to that chapter, it's not quite there. But maybe in a few years.
Makes sense. Maybe Copilot 2 or whatever it might be called. Maybe that solves everything.
Exactly.
So Again, reminder to everyone, please keep your questions coming. And in the later half, I'll cover the first two chapters. My next question would be, who would you consider successful students in this study group? Like, I'm sure everyone will spend 5-6 weeks together going through the book. Who would you consider successful?
Yeah, so I would say if you're able to reach the point where you can load and tokenize data sets and train models on them, and potentially even push them to the Hugging Face hub, I would say that if you're very comfortable doing that to the point where it's a little bit more like muscle memory. So when you're learning something, like you're reading or you're learning a new framework, right? Like, so for example, I don't know anything really about JAX. So if I was trying to learn JAX now, I wouldn't even know, like, what do I import, right? Is it like JAX is JP or something? So I think there's that process where at the start you're spending a lot of time kind of reading, going back and forth, trying to figure out, what do I need to solve the problem? Exactly. And at some point through a lot of practice, you end up having that kind of muscle memory. So nowadays in like my sort of day-to-day work, there's very little like having to read, say, tutorials and guides. It's much more low level, like reading the API docs. And so I think a sort of successful outcome from the study group would be to get to that point where you can think, oh, I would like to train a model on this kind of task or this kind of data set. And you sort of know in your head roughly, these are the kind of chunks of code that I need to set up. And the sort of less time that you end up having to look at the docs is a good sign of your progress through doing that. But I think in general, just again, writing code is like the key thing here. The concepts aren't hopefully so complicated.
That's a great benchmark. How less often do you refer to the docs?
Yeah, so I mean, I would say daily. I'm looking at docs across, like, especially the Hugging Face ecosystem or PyTorch when I don't understand or need to do something. But I've noticed recently with with Copilot that kind of transition. Well, it's a bit of the thing where, like, how often do you look at Stack Overflow or the docs? I'm finding I'm doing that progressively less thanks to Copilot. And of course, Copilot can't handle bleeding edge transformers or bleeding edge whatever because it has no idea, right? But if you're doing more like conventional stuff that's using existing APIs, it's quite good.
Thanks. I was just making a comment in general. It's very true to machine learning. How less often do you refer to libraries, docs, and that marks how like used to you are in that framework or how comfortable you are.
Yeah, and that actual process is, like, I think if you get very fast at doing that, that's very handy because it minimizes the sort of distractions you get. If you have to look up your stuff, like in Stack Overflow, right? A lot of the time I get distracted because I go there and then you're looking for something that is kind of close to the answer, and then you're like, oh, that's not quite right, and then you end up looking at the the thing on the side where they've got all these random top voted answers, and then you end up in a rabbit hole.
It's similar to Reddit in that sense, although it's
Yeah,
not
exactly.
intended to be. There's a question about what kind of hardware do you use in your day-to-day work? And if you could please unplug Silvan's water-cooled loop whenever you visit him next time, that would be great. That's my personal request. Please do that.
Okay, so I'll when I go to New York, I'll have to unplug it. Yeah, so I would say, funnily enough, most of the time I'm working on CPU, and it sort of depends what I'm trying to do, right? So if I'm trying to implement like a sort of, let's say, basic model class, and I just want to check, like, does the forward pass work? All that kind of stuff, which is, like, I think quite iterative and kind of like hacky, and you don't really know what you're doing. I personally just do that on my MacBook. So you don't have to have a huge model to do this stuff, right? You can just define the parameters, make it small, and then go back and forth. But then when it comes to sort of training and inference, usually I sort of tackle this in a progressive way. So I then will typically say, okay, let's see if I can run this, for example, on Colab or whatever, a V100 or something like this. That's kind of, I think, nowadays the sort of rough starting point is like, for a lot of the models that you work with. But lately, because I've been working with like large models, like in the sort of 10 to 50 billion parameter range, this workflow starts to break down a bit. And so I've found that now I'm needing to use like A100s, so like 40 gigabytes of VRAM and so on, as the kind of starting point to do, inference and also to, ultimately fine tune them. So yeah, CPU to V100 to A100 is like the transition, but I'm always a little paranoid about, wasting money. So it's, if you can use CPU for as much as you can, it makes your, also the development workflow is quite a lot faster as well. If you're able to just hack on your laptop and you can do it on the train, and it doesn't matter. Like if you always need to hook into a VM, it's a bit annoying.
Yeah, I think Andrei Karpathy also mentioned it. It's like the cognitive overload where you have to like figure out how to SSH, and then you mess up the ports, and like that itself takes an hour to just like set everything up.
Yeah, although VS Code is very good at that. Like the SSH part of VS Code is a life changer for me. Like I don't even think about it anymore. It's all this magic. So if you're using PyCharm, you're missing out.
But for me, like I launch containers on this shiny box, and then sometimes like I mess up how to connect to those. So maybe it's like just I'm the outlier, but sometimes that adds a level of friction
Yeah.
in VS Code. I think I'll ask this question by Money. He's saying, how do you see LLMs being used in custom NLP tasks? And so far, tuning the language models on domain dataset is the approach being done today.
Yep. Yeah, that's a super interesting question. I'm not sure what the future is gonna hold. I guess no one does, but in particular in this area, like I think one of the things that I'm not really sure about, right, is if you think about something like let's say the sort of GPT-3 to scale models, and more recently, ChatGPT, the kind of question I think a lot of people have is like, okay, do you want to have something that is like very general purpose, so kind of like an oracle that can answer very broad domain questions from physics to art to shopping lists, stuff like that? But if you're an enterprise, you probably care a lot more about like the ability of an assistant to answer questions on your in-domain data. So you can imagine like an enterprise, like for example, when I used to work at my old company, we had a wiki, and you have Jira boards, and you have all this kind of very, very technical knowledge, and there's lots of jargon that ChatGPT certainly doesn't know about. I mean, this is stuff that is like kept in the company, not outside, no one knows it. So I think an interesting question is whether these conversational agents will do the same. They'll take the same kind of route that we saw with traditional kind of language models, where you take something like BERT or Roberta or DeBerta now, and you then you fine tune it, and you get quite good performance on, say, in-domain data, and whether people will now see a new workflow of trying to do the same with the conversational systems, because a lot of the problems that you try to solve, right, in enterprise are around like information seeking, like how do you have customers maybe who want to like ask questions, or they want to complain or something, and you want to have a way of dealing with that. And it's not clear to me whether we'll see that kind of fine-tuning approach being applied in the same way, primarily because it's today quite expensive. You still need human labelers to look at the outputs of these models, rank them, do that whole reinforcement learning thing. So yeah, sorry, it's a bit of a disappointing answer of basically I don't know, but yeah, it's something to maybe keep an eye out for. And the other side of this is that despite the hype, right, despite how amazing this stuff is, most enterprises aren't gonna like do this, right? I mean, like you probably know, right? Like a lot of my old job was like SQL magic, like that's the stuff that brings value. And deploying your big fancy transformer into production, that's like the kind of nice to have. So
yeah, we need a chat SQL.
exactly.
Christian, who's an amazing practitioner, is saying bring your own data as an OpenAI's roadmap. So maybe they'll add it in the future.
Yeah, yeah. I think one of the sort of main challenges that like OpenAI and other companies face is like, for example, I live in Switzerland, and the companies here are like extremely protective of their data, leaving any sort of premise, right? So the idea that you would send your data to another company is kind of essentially an impossibility, I would say, from a like a legal perspective today. Um, I think maybe the closest I could see is like there are companies like Mosaic that are trying to kind of allow people to kind of train or have sort of optimized ways of training models like as developers. But yeah, unless that kind of more human legalistic stuff gets solved, I feel like you're always going to be stuck at least on maybe more just the US market or domains where public sensitive private sensitivity is not an issue.
Thanks for that answer. I had blogged 1 hour of Lewis's time, and I said that the Q&A will take 30 minutes, but it might run over, and it did.
No
So
problem.
I just wanted to thank you again for your time and also writing this book. I'll mention your Twitter, which I believe is the best place for the audience to find you. Any other
That's right.
places that I may mention?
That's probably it. I mean, technically I'm on LinkedIn, but I only do it because other people seem to have migrated there. But I'm mostly on Twitter, or in fact, I'm actually probably more active on GitHub than Twitter, so you're probably better off stalking me there.
But as long as people don't open issues saying it's an amazing book, that's fine.
Exactly.
Thanks again, Louis, for your time. I just wanted to start with an ask me anything with you, and we'll definitely spend the next few weeks enjoying your book. Thanks again for writing the book and also your time for joining me during the kickoff session.
No, thank you so much for having me, and thank you everyone for these really interesting questions. I know we talked almost more about ChatGPT and stuff, which is I think relevant because it does seem to be a sort of seismic shift in like how the community is thinking about what to build next. So yeah, I'm pretty excited to see how a lot of the things that are in the book and also what we work on at Hugging Face hopefully will become the next step towards other people having access to this technology.
Yeah, it was still an interesting discussion, so thanks for it. Please feel free to close the tab. I'll continue the study group from here, so I'll use the same link for it.
Okay, great. Bye, Sanyam, and bye, everyone.
Thanks, Louis. All right, everyone. We'll continue with the study group now. So what I'll try to do is cover the first 2 chapters. And I want to get back to some people who are trolling me. So Ayushman is saying MS Word is the best programming interface. I agree with him. Yes, that's the best. That's the most superior one. All right. So my agenda for today was to cover the first 2 chapters. And once again, I'll mention that you can join the forums where we'll keep the long form discussion going. So these are open in one tab, which I'll find eventually right here. Please feel free to introduce yourself in the forums and also ask any questions there. The live chat is for keeping live discussions going on. I found that works the best. And as I've been mentioning, this study group is for you all. So whatever you end up finding better, I'll stick to that. I'm seeing some other questions. So in case I missed any, please feel free to ask that. But what I plan to do now is cover the first 2 chapters as much as I can. We might go over an hour. And the easiest way to join the future study groups is just subscribe to the channel if you're interested. And let me also point you towards how you can join the next one. So if you head over to the channel in the live tab, you can find the next live stream page up already. So you can just click to be notified here if you'd like to join that one. And I think we'll cover chapter 3 and 4 there. So that's the agenda. For the next one, let me quickly outline what I plan to cover in this remaining live stream. So my goal is to help all of you understand how these different pieces come together inside the Hugging Face ecosystem, which will keep going through under different iterations. You can go through it in different approaches. There's like the easiest pipeline function. which you can see, or you can also work at different abstraction levels. So we'll look at what all of these pieces are and how do they come together. In chapter 2, we'll learn how to classify between these different categories. So the text we'll be looking at has all of these emotions in it, and we'll learn how to classify that. I'll also always try to supplement the material. So I'm using Jeremy Howard's incredible tutorials on Iterate Like a Grandmaster, and also in Getting Started with NLP Guide. So we'll be taking a look at that. And I'll also keep sharing resources like this one by Jay Alamer, or also a few publications, for example, Distill Pub's attention visualization, which I found to be like really cool. You can see that I'm hovering my mouse here and it's like showing you how attention works. So we'll keep looking at these resources. And let's get started with the first notebook. So this is literally taken from the GitHub repository. And what I'll do is I'll quickly run through all of this. And how should I go about that? I was thinking a lot about that. And they start by introducing you how pre-training works in the context of the book. So I thought I could showcase a tool by the H2O AI team. They've created an amazing resource on working with deep learning based models. So through that, I'll try to explain what pre-training is and how do you work with these models. This is a no-code deep learning tool. It's called Hydrogen Torch, and my intention is to help you understand how pre-training works. A few of you were asking if this group for students, is it for practitioners? It's open to everyone. So I'll what I'll do is I'll be covering concepts from a base level, and we'll keep going through all the notebooks, and I'll also share papers in the later half. I'll also actually read papers. So my intention is also to cover the attention paper, the sequence to sequence paper, and different papers covering distillation and such techniques. So it's open to everyone. You can pick what you choose. Your feedback is always welcome. Just shout at me in the forums or in the comments if you don't enjoy it. Have I considered adding a calendar invite? No, I have not, because if you go to the YouTube page that I mentioned, you can just see the time in your time zone. So that's the easiest in my opinion. But if that does not work, let me know, Dylan, and I'll make a calendar invite. So I was going to mention what pre-training is and how that works. So for that, what I'll do is I'll create a experiment for token classification. What is token? What is all of this? We'll just learn that in a few minutes. But for now, just understand, simply put, you're trying to identify different pieces inside a paragraph. So let's say you're trying to identify which word refers to an organization, so on and so forth. So what I'll do here is I've set this experiment to a master level. And as you can see, it's prompting me to the train data frame and the validation strategy. And it's identified this as an NER tags problem. If you don't know what that is, don't worry about that. I'm just using this to explain a few concepts. So even when loading all of this data, I can toggle lowercase on and off, and I can set the max length. And we'll see in code what these mean. But max length simply tells you the maximum length of the input sequence, or how much of the input sequence you want to feed to your model. Now, depending on the backbone that you end up choosing, and as you can see, I have chosen bird based uncased. You can also work with Distill GPT, or you can choose all of these different backbones. My favorite is Roberta base, as I was saying earlier, and it's probably the favorite of all Kaglers. When I do this, what happens inside Hydrogen Torch, or when you're writing code in using the Transformers API, this model that has been pre-trained on some NLP data gets downloaded, and we fine tune it towards this particular data set. So what that means is similar to how you work in computer vision. You have models trained on ImageNet. Although there's no standard ImageNet for NLP, we download these models and apply them to our target data set. How does that happen? Basically, the final head of the backbone gets changed, and that's what we end up fine tuning while we're working with these. You can play with the max length, you can apply different strategies. You should also ideally work with differential learning rates. So in Hydrogen Torch, it's as simple as just selecting this. And when I do this inside any neural network, there are a lot of layers. And you should be applying differential learning rates to them in the sense that the backbone is usually well trained. So you could have a lower learning rate for that, and the head could have a higher learning rate. And after this, I can simply run the experiment and see how that ends up performing in this interface. And to show you what this ends up achieving is, I can look at the input text and the target text and what's being predicted here. And if this was an NER named entity recognition task, which I was pointing to earlier, it would have identified that Virginia is a place or middle school is an organization, so on and so forth. What's happening here is we're downloading the backbone and working with that. And we'll now look at how can we do that with the open source Hugging Face API. Of course, this tool is for organizations. So if you want to work and give really high performing, get highly performing models or high performance, high accuracy models, you can check out Hydrogen Torch on H2AI's website. But I just wanted to give you a taste of what all of these tools can achieve. And all of this started in a way with ULM Fit paper, as the authors mention inside the book. So this was actually written by Jeremy Howard as well, whom we were talking about earlier. And what they ended up achieving was, at that time in 2018, pre-training language models was not common at all. So we had something known as RNNs, which look like so. And you have this hidden state which can be unrolled and represented like so. So you have inputs going into an RNN cell which sort of loops over itself and gives you hidden states. But at that time, no one was pre-training this on any data set. So once ULM Fit came along, this is the paper. The authors Jeremy Howard and Sebastian Ruder pointed out that you could pre-train this on a data set or your language model on a data set and then fine tune it towards a target problem. Let me see if I can find the visualization here. So they pre-trained it on wiki text and then fine tuned it towards the later target problem. I'm just trying to find the visualization that points it out if I can, real quick. Yep, here it is. Sorry for the slight delay. But as you can see, for ULM Fit, this is a high level overview, and this introduced everyone to how you can make pre-training work. So you have a language model trained on Wikitext 103, which essentially is like Wikipedia. And from there, you fine tune the language model on IMDb. And then finally, you change its head into a classifier. So from there, you can predict the sentiment of the review. So this simple, somewhat simple in retrospect, this simple demonstration ended up creating the transformer revolution, and that spawned all of these models, which we'll learn about in the next few weeks and how you can work with them. Will I cover training transformers from scratch? Yes, I'm just about to do that in a second. And I think we'll also get to training our first transformer model today. So a simple way of looking at transformers is, instead of having the vanilla encoder and decoder blocks that go through a state, you can also think of it like this. So this blog post is by Jay Alamer, and he gives you in the illustrated transformer a high level overview of a transformer. So there's an input and output, and it's what is known as a sequence to sequence model. The encoder encodes this input in the form of a representation in memory. And from there, it's passed on to a decoder. This is like overly simplified, but this is what happens inside transformers. The decoder from there takes this representation and gives you the output. So that's the encoder decoder setup. Now, what transformers ended up achieving was they created, or they emphasized, the use case of attention. What is attention? I have another blog open to show you that. So this is by DistilPub. And if you want these links, I'll link them under the like button after the live stream. So don't worry if you need these links, they'll be up in a few minutes. It's called Attention and Augmented Recurrent Neural Networks. And what it's trying to do is it's trying to teach the model how to pay attention to different words. Simply put, it's just giving weightage to different possible states or outputs. So when you create an attention matrix or an attention layer, out of all of the possible states or outputs, it's giving different numbers or weightage to all of these cells, and that's generating the output that we care about. So if you plot the heat map like so, you can see that this is the attention it's giving to different words while generating the output. And this is again a simplified representation of how the encoder and decoder blocks work with attention. So next, the authors talk about transfer learning in NLP. Sahil is saying he can't stay for the entire session. No worries, Sahil. And for everyone, the video will remain up on the channel and all of these recordings are instantly available. So don't worry. But for transfer learning, here's what essentially happens. You train your model on a certain domain, which gives you a model A that gives you some predictions. And then to fine tune it, you can just use this model on a target data set and change the head. So you can see in domain B, you still take the body of model A and just change the head, which gives you a prediction. So I repeated this 3 times in the last 1 minute, and that's just to emphasize how pre-training works. So when you go to the Hugging Face hub, or when you try to download a model from Transformers, you're actually downloading body of A, and then that's what you're fine tuning towards the later end. So in the first chapter after this, they give you a tour of different applications that are possible with Hugging Face Transformers. And they start with this text, which is complaining that you got the customer, which was Bumblebee, got a Megatron Decepticon instead of an Optimus Prime. And they teach you how to work with this and classified sentiment. So for that, they import the pipeline function from Transformers and initialize it to text classification. So inside this chapter, they're giving you how you can work with the most abstract layer, which is pipeline. So depending on how custom your data set is and at which level you're operating, you could have different levels of functions you're working with. This is the most abstract one where you simply import pipeline and initialize it to text classification. Once you've done that, you can simply grab the outputs from the classifier and it'll tell you if it's a negative or a positive uh, paragraph. So it correctly identifies that as negative. And one thing to point out, these are fairly easy to interpret with Pandas data frame. So you can simply create a data frame around the output and get that. You could also create a named entity recognition model. The thing I was trying to point out earlier in the GUI interface. The simpler way to do that in Hugging Face API is to create a pipeline function, initialize it with named entity recognition, and just grab the outputs. So it will identify the organization as Amazon. Optimus Prime gets identified as miscellaneous, which I'm not happy with, but that's what it is. The location is identified as Germany, and as you can see, it identifies different words as different entities. So that is name entity recognition. This is important when you're trying to summarize or understand different paragraphs. So let's say you like have a really long page of text. You as a human could still read it, right? But if it's let's say legal text or something complex, it's still hard to interpret all of that. So that's a cool or easy application where such models are really relevant. Someone is joining us from Algeria. Great to see you, Kokod. So that is what named entity recognition is useful for. You could also have question answering models. So you could simply ask the model, and this is somewhat similar to ChatGPT, which we were talking about. You could ask the question, what does the customer want? And then you pass this question to the model and also the context. And it can simply tell you that, hey, it wants an exchange of Megatron. So it wants the product to be returned and a new product to be given. You could also summarize your text like so. So you pass the summarizer or you collect the object in a summarizer variable where you pass summarization to pipeline. And after doing that, you simply pass the text to it. You can pass the max length, which I pointed out earlier. So that's what I wanted to point it. That's why I wanted to point out that. Someone is saying the code is not visible. Is it true for everyone? Should I zoom in more? I think this is fine, right? I'll continue with this, and if it's not fine, please let me know. So you can pass in the max length, which as I showed earlier decides how much of the text do you want to pass in, or how much output in this case do you want to generate. And then you can also have additional parameters that I won't mention here. So this gives the summary of the inputted text. People are saying the code is fine, so I'll continue. Thanks. Thanks, Dylan. You could also translate these models. So now we're getting like one layer into the abstraction. So far, we don't know what language models we're using. We don't know what backbones we're using. We're simply passing different tasks inside a pipeline function, and we're blindly trusting this function so far, right? So what we're doing here is we're passing a specific model. And as we go through different weeks, we'll also see how to pass different models, how to work with different data sets, how to load all of these. All right, so it's not possible for me to hide my self to the right. I could just hide myself like this, so you won't see me. I think that's fine. So I was coming to how abstract pipeline is, but as you can see, you can also select the model that you're working with. If you don't pass anything, pipeline will decide for itself. But that does not mean you're not using a particular function here, right? Or a particular backbone. It just means that the pipeline function is deciding it for you. So you could also pass this function and then decide to translate it. So simply pass the text to translator now. And you can say that, hey, at least make it minimum 100 tokens. You could also generate text. So this time we set the pipeline to text generation. And we start with the response and send this prompt to the generator. So we use this text and the customer service response and pass this prompt to the generator, which gives us this somewhat legible output. So this was a very high level overview of how you can load in different pipelines and work with different things and the tasks that are supported by pipeline. We'll keep looking at tokenizers. We'll look at transformers, data sets, and accelerate. That's notebook 2. So we'll be taking a look at that. I also wanted to use Jeremy Howard's notebook to outline getting started with NLP. So let me get to Kaggle and point out this notebook real quick. To credit, Jeremy has written this notebook and I'm simply referring to it. So this gives you an insight into how to get started with tokenization and how basically the ground basics of NLP work. If you just search on Kaggle, you should be able to find this. I won't highlight the link since it's too long. So this is in reference to this competition called US Patent Phrases. And we'll come back to this in the next week because I'll share another notebook relevant to that. But for the purposes of today's lecture, this notebooks walks you through the ground basics of NLP. So Jeremy in his notebooks point out that these are the following tasks that NLP is widely used with. It is used with sentiment analysis, author identification, legal discovery, organizing documents by topic, and figuring out inbound emails. So classification models can be used for the first few problems, and you have different tasks that you can work with, as I showed earlier. In this notebook, he also makes the argument for why you should be on Kaggle. And over the next few weeks, as we meet every week, I'll show you how you can apply the same things to different Kaggle competitions, or I'll also have Kagglers join in future lectures. So we'll also learn how to apply this knowledge that we learn in the study group to future Kaggle competitions or current Kaggle competitions, even for that matter. So coming back to this notebook, it teaches you how to set up the kernel. So I'm scrolling past that, but you can read through it if you want. What is the default backbone used in HF pipeline? I think it's an accessible attribute. I'll come back to your question, Bharat, in a few minutes. So you load in the data set here, and Jeremy basically does some EDA inside of this notebook. And he points out that usually documents in NLP tasks are in one or two formats. It could be one text file per document. So you have like text files inside folders and a large number of those. Or you could have a large CSV file with smaller documents. Once we go back to the second chapter, we'll see how we can work with data sets in the form of CSV, or you can also download the data sets directly through this class known as data sets. But those are the most widely used formats of representing the data set. And inside this competition, it's just CSV files. So he loads in pandas and shows you how the data set looks like for this problem, and points out how many number of rows and columns exist inside this data set, which I'm skipping past. So here's what's relevant to us today: tokenization. And he says transformers use a dataset object for storing a dataset, which you can create simply by importing the dataset object, dataset function, and you can pass in the data frame to it. You can then print the dataset, which will tell you the features it has and the number of rows. Now, the challenge with all of this is you can't pass text directly into model. Neural networks are basically simplified matrix. In simple English, there's this matrix multiplication of like very large sizes. So you need a way to pass numbers to neural networks. Language models are also neural networks with a large number of parameters. So how do you go from these text to those number and then back to the output text or sentiment or whatever you care about? For that, you do tokenization. You split each text into words or tokens, and then you convert all of these into a number. So for the demonstration, Jeremy has loaded Deberta v3 small. And by the way, this is the standard way of passing in the model to Hugging Face API. So what you do is you can just search the models on the hub. So if you just go to the Hugging Face website and let's say you search for Deberta v3, I can just copy this by clicking here, or I can select and copy it, and then you just pass that full string to the function. So for simplified purposes, you could also use auto tokenizer, which will create a tokenizer appropriate for whatever model you're working with. And Hugging Face has many such classes. So I was pointing out earlier about how much the team has put thoughts into creating all of these frameworks. And you'll see auto model as well later on, and you'll see different such classes which take care of a lot of things. So you could either custom define it for your case, or if you don't want to mess up, you can just use auto tokenizer. And that is quite important when working with models. And we'll also see why that is important next week, I believe. So what we do here is we create an auto model for sequence classification and import auto tokenizer. And we simply pass model name Deberta v3 small from earlier. Now we can take a look at how the tokenizer splits text into tokens. So he's passed the text, good day folks, I'm Jeremy from FastAI. And you can see that uncommon words will be split into pieces. And the start of a new word is represented by underscore in this case. Dylan is saying auto tokenizer is an amazing time saver. I agree with him. So you can also parse a very strange sentence and you'll see all of it pretty much will be represented with underscore, because start of new words is represented by underscore, and uncommon words, as I said earlier, ended up in pieces. A simple function that can tokenize our inputs can be written like so. So you can simply return the TOKZ of the input. And to run that in parallel, we can use a map function which we'll use constantly. So how this works is you'd usually define a function, and then on the dataset, you call the map function to which you simply pass this function that you had created earlier for tokenizing. Why do we do that? Because it allows you to batch this function and run it in parallel. What does that mean? Most of the times you have a multi-thread CPU, so you have more than one CPU cores, and you'd want anything to run fast. When you said batched is equal to true, it runs in parallel across all your CPU cores, and it basically runs faster. So if you have four CPU cores, it'll run four times faster, so on and so forth. So always do that. Let me hide myself because before someone gets mad. So after you've done that, you can see that the input that we pass to the model gets converted to text like so. So now this is what we can pass to the model. And where are these coming from? So Jeremy points out that all of these models have something known as a vocabulary inside the tokenizer, which decide what these texts are. So Dylan was pointing out earlier that auto tokenizer is a lifesaver, and that's because these numbers for different words are different for all tokenizers. So you don't want to mess that up, and it's quite easy to mess up, honestly. So this is helpful in that sense, that auto tokenizer by itself figures out what model you're working with. If I scroll up to it, so let's say I pause model name Deberta V3 small, it'll figure out, hey, that Deberta V3 small uses one particular tokenizer, and it'll take care of importing that. You can't mess it up. It'll just import whatever's required there. After this, in the notebook, he shows you how to set up the validation data and also how to get the first predictions. So my goal is to come back to this next week. And I wanted to cover a few more topics, but I think we can wrap up around this. So tokenization is simply converting text into numbers and then coming back to numbers. And we do that by using the dataset class. And all we've done today is we've looked at pipeline function, and we've looked at the different applications that the Hugging Face API supports. We've also taken a very brief look at what datasets can do. So my goal was to cover chapter 1 and 2, but I like to focus on quality instead of quantity. So we'll come back to chapter 2 next week. I'll try to cover chapter 2 and 3, maybe as well 4 in the next one. All right. So I'm just catching up on the chat, but I think we can wrap up here. I'll mention the forums again, so you can join this community to chat with other people. Community.h2o.ai, or you can just subscribe to the channel for the next meetup. It's already up, so you can keep an eye out for that. But my agenda every week is to share this learning with everyone, and together as a group we'll just summarize what we've learned in this book every week. So every week I'll come back, I'll go through the few chapters in sequential order. My focus is always to make sure everyone learns properly instead of just running through the book. So next Saturday at the same time, we'll be going through chapters 2 and 3, and we'll keep meeting each week. I'll also show the different external resources that you can use for learning. But I'll see you next week, and we'll go through chapter 2 and 3 then. I'll wrap up here in the interest of time, because I know more than an hour isn't ideal for everyone. So I'll see you next week. What is the homework? That's a great prompt. Thanks, Yash. Let me point that out. The homework I had for everyone was to join the community and run the notebooks. And I mentioned the notebooks earlier, so you should check those out. The notebooks by Jeremy Howard. That's all the homework I have for you guys. Simply put, just run the code from this book. And if you haven't already, please consider buying the book to support the authors. And if you end up doing any of this, please tag me as well when you do that. One more thing, I'll announce uh, some giveaway winners. So Lewis had shared 3 books, which I'll be sharing to people who had asked great questions and anyone that ends up leaving a comment. So if you're already active, you might win a book next week. 3 people will win a book, which I'll announce in the next live stream. All right, I'll wrap up now. Thanks everyone.